Hi, today we will talk about simple functions. Function on its own provides a relationship between input and output. So when you have a function f with an input x, you can easily produce an output y. To give you a simple example, we have a function f with an input x equal x plus 4. We rewrite it as y equal x plus 4. And to find a solution to such a function, we need to draw a sketch on a graph by finding intersect points on x and y axis. To find intersect point on x-axis, we need to substitute y with 0 and insert it into our function. So we do know that we have substituted y with 0. We insert into our function, which gives us 0 equal x plus 4. We put numerical values on one side, leaving x on the other, and we have left with minus 4 equal x, or x equal minus 4, which gives us our first intersect point, which is on x-axis with value of minus 4. Then, to find the intersect point on y-axis, we substitute x with 0 and insert it in our function. So we denote that we substitute x with 0, we insert in our function, and we get y equal 0 plus 4, which is y is equal to 4. This is our intersect point on y-axis with value of 4. Now, as we have our two intersect points, we can easily draw a sketch on our graph, which is a straight line going through our intersect points. There you go. Take an example would be a more sophisticated function, such as f with an input x equal minus x squared plus 3x. Again, we rewrite it as y equal minus x squared plus 3x. Finding a solution, we need to find intersect points on y and x axis. Firstly, to find intersect points on x axis by substituting y with 0. We insert in our function, which gives us 0 equal minus x squared plus 3x. We can see that we have a common factor x. We bring it before the brackets, and we leave what's left inside the brackets, which is minus x plus 3. Here you can see that there are two answers. One would be x equals 0 as x appears outside the brackets, and the second one would be minus x plus 3 equals 0. Then we bring the numerical values on one side, leaving the x in the other, which gives us 3 equal x, or x equal to 3. Here we have our two intersect points on x-axis with values of 0 and 3. Because there are two intersect points on x-axis, we can see that there is a function, a parabola, rather than a straight line. To find the beginning of the function, we need to find the coordinates of x and y. Firstly, to find the coordinates of x value, we simply find the average of intersect points. To find this, we add our intersect points, which is 0 and 3, and divide them by 2, which gives us a value of 1.5. And then, to find coordinates of y, we simply insert 1.5 into our function whenever we see x, which is y equal minus 1.5 squared plus 3 times 1.5, which gives us minus 2.25 plus 4.5. And we have y equal 2.25. Here's our y values of beginning of the function point, which is 2.25. we can denote on our graph that this is our beginning of the function point. And because the x squared has a negative sign before it, it tells us that the function is facing downwards. So we draw our sketch with function going through intersect points and beginning of the function. The third example would be functions such as f with an input x equal x squared plus 2x minus 3. Again, we rewrite f with an input x as y. Finding the intersect points on x-axis, we substitute y with 0, and we have 0 equal x squared plus 2x minus 3. Here you can see that to find the solution to such an equation, we need a help from quadratic equations formula. If you don't remember what it is, I think this will ring you a bell. Minus b plus minus square root of b squared minus 4ac, everything divided by 2a, whereas a is here, b over here, and c over there. We put our values into quadratic equation formula, which gives us minus 2 plus minus square root of 2 squared minus 4 times 1 times minus 3, all divided by 2 times 1, which is equal to minus 2 plus minus square root of 16 divided by 2, and that is minus 2 plus minus 4 divided by 2. Here we are finding two values. The first one would be x1, which is equal to minus 2 plus 4 divided by 2, and that's equal to 1, and x2, which is minus 2 minus 4 divided by 2, and that's equal to minus 3. Those are our two intersect points on x-axis with the values of minus 3 and 1. Then finding our beginning of the function point, we find the middle value of intersect points on x-axis, which is minus 3 plus 1 divided by 2 equal to minus 1. We denote it on our graph and we insert it in our function, which gives us y equal minus 1 squared plus 2 times minus 1 minus 3, which is 1 minus 2 minus 3, and that's equal to minus 4. We put it on our graph and we have our beginning of the function point, and the last thing we need to do is to find intersect points on y-axis by substituting x with a 0 and putting in our function, which is y equal to 0 squared plus 2 times 0 minus 3, which is on its own minus 3. We denote on our graph on y-axis, and here we have all our intersect points and beginning of the function point. So we draw our graph. Because the x squared has a positive sign, that means that our function is facing upwards, and we draw our sketch which goes through our intersect points and beginning of the function point. If you have any questions, please leave them in the comment section. We will try to answer them all. Thank you.